Hey everyone, welcome to our lesson 5.6. Today we're going to begin looking at graphing linear inequalities, which we're going to look at for the next couple sections. Today you'll want to use graph paper for your notes, so make sure that you take a moment to pause the video, get a piece of graph paper, and set up your note sheet with the section, the date, and the I can statement, and then go ahead and resume your video. All right, so we're going to look first at a couple examples of inequalities and how we graph them. And we looked at inequalities a lot back in chapter 2, but that was just with a single variable. So now we're looking at inequalities that have two variables, which means that we're going to be able to graph them just like linear functions. And so we're actually going to start, like when you see an inequality like y is greater than x plus 5, the easiest way to approach this is first to treat it as though it was y equals x plus 5 for the sake of graphing. In other words, we know that our y-intercept is going to be 5, and our slope, our m value, is going to be 1 in this case. So I'm going to start by just graphing y equals x plus 5 to begin with. So go up to my y-intercept of 5. It's a little hard for me to see, but I think that's close. And then we're going to go up 1 over 1. And we'll continue to do that as much as we need to so that we can draw in our line for y equals x plus 5. Now, one thing to pay attention to here is we're going to either use a solid line or a dashed line depending on whether our symbol includes equal to or does not. And in this case, we have a y is greater than, but not equal to. And to indicate that, we're actually going to use a dashed line rather than a solid line. So I'm going to come in and just turn my solid line here into a dashed line to indicate that the points on the line itself are not solutions to this problem. So now the next question is, we want to shade, because this is an inequality, we want to shade all the points that make this inequality true. And there's infinitely many points. So the answer is not just one point, it's an infinite set of points. And the easiest way to decide whether you're going to shade above or below the line is just to check whether or not the point 0, 0 is true or not. If the point 0, 0 is true, we're going to shade wherever 0, 0 is. And if it's false, we're not. So in this case, if I plug in 0, 0, I would have 0 is greater than 0 plus 5. Or in other words, I would have 0 is greater than 5. Now, pretty clearly that's a false statement. 0 is not greater than 5. So in that case, I'm not going to shade the side where 0, 0 is. Instead, to indicate where my solutions are, I'm going to shade everywhere where 0, 0 is not. That entire space that's shaded in, this whole area, every single point in this area represents a point that is a solution for this inequality. So I can't really say, tell me the solutions to this. It's impossible to tell you verbally. You'd have to list infinitely many points. But when you shade, you can use that to show all the points in sort of a more picture-oriented manner. And that's the way that we're going to show our answers to these problems. So if we look at another example here, y is less than or equal to negative 1/2 x plus 1. We've got a y-intercept of 1, so I'll put a point at 1, and a slope of negative 1/2 x, which means we go down 1 over 2. So I'm going to go down 1 over 2, down 1 over 2, and draw on my line. Now in this case, our line is going to be solid because we're less than or equal to. Now your lines will obviously be much better than mine because you'll be able to see much clearly and ideally use a ruler. But let's say our line looks about like that. So again, to know if I'm going to shade above or below, I'm going to check 0, 0. And in this case, when I check 0, 0, I have 0 is less than or equal to negative 1/2 times 0 plus 1. or in other words, 0 is less than or equal to 1. And that is a true statement. So in this case, I'm going to shade where 0, 0 is. So I'm going to shade everywhere underneath the line because that includes the origin point 0, 0. And that'll represent all of our solutions. Now, you might notice here that when we are greater than, we're going to shade above the line. When we're less than, like in example B, we're going to shade below the line, which makes a good deal of sense. And that's true, generally speaking. It depends a little bit on the location of y. So you have to be a little bit careful with that, but that can be a true shortcut most of the time, and it's good to double check by checking the point 0, 0. So let's write out some steps for graphing a linear inequality that has two variables. The first step that I would recommend, just to save you time, is to first determine the line type that we're going to use. So in other words, we're going to decide if it's solid or dashed before we start, so you don't have to erase anything. So if you have a less than or a greater than, we're going to use a dashed line. If we have a less than or equal to or a greater than or equal to, we're going to use a solid line. So then step 2 is going to be that we're going to graph the inequality as though it was instead an equation. In other words, we're going to pretend like it's equal to for a second. Graph it using slope-intercept form or whichever form you would like. And then finally, we're going to shade as needed. And there's really 3 ways you can do this. One is the one that will always be correct, which is to check 0, 0. But 2 and 3 are sort of shortcuts as you start to get good at this. So if it's less than or equal to, generally speaking, you're going to shade below the line. And if it's greater than or equal to, generally speaking, you're going to shade above the line. However, this is only true after you've already solved for y. So you have to be a little bit careful not to look at the original equation, but instead look at it after you've solved to get y all by itself. And we'll look at an example of this now. So let's look at another example here together. X minus 2y is less than 0. Now, when you see that less than sign, that might tell you that, hey, I think we're going to shade below this line. And what you're going to find is that actually, in this problem, turns out to not be the case. And so we're going to look at an example of that right now. So the key here is before we can graph this, we want to solve it for y, to get y all by itself, to get into slope-intercept form. So I'm going to subtract x from both sides, and I'll have negative 2y is less than negative x. Then we're going to divide both sides here by negative 2. And when we do that, you got to remember we're dividing by a negative, so we have to remember to flip the sign. That's something we practiced a lot earlier this year and in pre-algebra. So we'd have y is greater than x over 2. And that tells me that my y-intercept is going to be 0, 0, and my slope is going to be 1/2. So the other thing I'm going to notice here is that because we've got a less than sign, we know that we're going to use a dashed line. That's step 1. Determine if your line is dashed or solid. So now we're going to go ahead and graph this, step 2. And so our y-intercept is 0, 0. Our slope is 1/2, so up 1 over 2 each time. And we can go down 1 and over 2 in the other direction as well. And then we're going to draw in a dashed line. And we're always going to remember our arrows because these are lines, not line segments. And then finally, we need to decide whether to shade above or below. And you'll notice here that we can't check 0, 0 because 0, 0 is on the line in itself. That won't tell us anything. So instead, we need to pick a different point to check. And just for the sake of it, I'm going to pick the point above 0, 0. So in this case, I'm going to check 0, 1 directly above it. So in that case, if I plug that in, I would have 0 minus 2 times 1 is less than 0. In other words, negative 2 is less than 0. That's true. So that means I'm going to shade where 0, 1 is. And 0, 1 is right here above 0, 0. So that tells me I'm going to be shading above the line for this problem. And what I want you to notice here is a couple things. One, we couldn't check 0, 0, so we had to try a different point. Two, if you look at the original problem, it said less than, but we ended up shading above, and that really came from here at the end when we had y is greater than. So it's just something to pay attention to make sure that you don't miss things. All right, so the next thing we're going to look at here is how you do this on your graphing calculator as well, because it's actually pretty cool. Our graphing calculator can graph inequalities for us. So if we want to graph 5x minus 2y is less than or equal to -1, the first thing we need to do is solve for y, because we need to get into y equals form so we can put it into our calculator. So the first thing I'm going to do is I'm going to subtract 5x from both sides. So we've got -2y is less than or equal to -5x minus 1. Then we're going to divide both sides here by -2. And remember to divide everything by -2 so that you don't miss something. And then also we have to remember to flip the sign because we divided by a negative. So we have y is greater than or equal to 5/2 x plus 1/2. So now we can put this into our graphing calculator and see what this looks like. Now, I do want to point out that I'm showing you this because I want you to understand how your graphing calculator works. But on your homework, I want you to be doing your graphing by hand. The only exception would be word problems if the numbers are so big that the window really requires that you do it with a graphing calculator. If it's not a word problem though, I want you to be doing it by hand. You can check with your graphing calculator if you want to. So I'm going to type in 5/2 x here, plus 1/2 into our y equals. And then to make this an inequality, I'm going to scroll back over all the way to the left until I get this flashing symbol on the far left. And now if your calculator is newer, it's going to send a pop-up window that'll allow you to change it to an inequality. For the older calculators like mine, you just hit enter until you get to the one you want. And in this case, we want to graph greater than. So I would choose the flashing triangle that is above, rather than if I hit enter one more time, you'll see this would be the less than inequality. So because ours is greater than, I'll go back through it again to get back to the beginning here. So I'm looking for the one that's greater than. So now if I hit graph, I'm going to see my line as well as the shading above the line as a greater than graph. So that's how you graph with your calculator. You're only going to do this for word problems or to check your answers on your homework. All right, so our next example here is what if we want to work in the other direction? We want to write an inequality represented by the graph. So the things I would notice here is I'd probably start by recognizing that we're shading below. So I know for sure that I'm going to be using a less than sign. And I also see that it's a dashed line. So I would use less than rather than less than or equal to. On the right side, all we have to do to write our inequality is check our y-intercept and our slope. In this case, our y-intercept is right here at -3. So I know that I'm going to put a -3 on the outside. And our slope here is up 1 over 1, up 1 over 1, which tells me that our slope is 1. In other words, I could write it as 1x, but even better would be to just write it as x. So our inequality that represents this graph would just be y is less than x minus 3. So our last example for this video is looking at a word problem. So let's say that we can spend at most $12 on red peppers and tomatoes for salsa. Red peppers cost $4 per pound, and tomatoes cost $3 per pound. We want to write and graph an inequality that represents the amount of red peppers and tomatoes we can buy. And we are also asked to identify and interpret two solutions of the inequality. So in this case, the first thing I'm going to do is I'm going to define my variables. So I'm going to say that x is going to be the number of red peppers I can buy, and y is going to be the number of tomato, or the pounds, I should say the pounds of red peppers I can buy, and the pounds of tomatoes that I can buy. So in this case, I can spend at most $12. So I usually start with the total, just like we've talked a lot about for word problems. At most means less than or equal to, and I can spend at most $12. Now, red peppers cost $4 a pound, so that'd be 4x, and tomatoes cost $3 a pound, 3y. So my inequality would be 4x plus 3y is less than or equal to 12. Now, there's also two other sort of implied inequalities here that I'm just going to write down because they're obvious but important. We know that x has to be greater than or equal to 0 and y has to be greater than or equal to 0 because we can't have negative pounds of tomatoes or negative pounds of peppers. And that's just important because it'll influence our graph a little bit. So in this case, I'm in standard form here, so I'm going to use standard form. If you cover up y, the 3y, you can see that 4x is less than or equal to 12. In other words, our x-intercept is going to be 3. And then if you cover up the 4x, you can see that 3y is less than or equal to 12, so our y-intercept is going to be 4. And because it's less than or equal to, we're going to use a solid line. And then in this case, we know we have at most, so that means we're going to be shading under the line. Now, I'm not going to shade it all into the negative regions of this because it's impossible for me to have a solution that includes negative pounds of tomatoes or negative pounds of peppers. So some example solutions might be a point like right here at 1, 2. That would be a solution. I would buy 1 pound of red peppers, 2 pounds of tomatoes. I would end up spending $11. Well, actually, no, I apologize. I would end up spending 4 plus 6. So I would end up spending $10 at that solution point, which is less than or equal to 12. Another solution point might be something like right here. I could say, okay, my solution is 3, 0. I'm buying 3 pounds of red peppers and no tomatoes at all. That'd be a really weird salsa, but you could do it. You would spend a total of $12. So these, when it says identify and interpret solutions of the inequality, solutions can be on the edge or in the middle of the inequality. So that brings us to the end of our lesson video for 5.6. Obviously, you'll want to use graph paper for your homework. So give that a try and let me know if you have any questions.